All right, so this is mini lesson 2 from 3.1. It's part 2. This one's on complements. So we've developed an idea basically of what probability is. Now what we want to do is we want to build on that idea and add more layers of knowledge about different kinds of probabilities or the ways that we can use that basic idea of probability and add some more vocabulary to it. So this next one is called complements. So let's say, for example, we have an event A. The complement of the event A, then denoted as A complement or A bar, is all of the events in the sample space that are not A. Okay, so we have a sample space, and this idea of sample space is very important from this perspective because we have the idea of the sample space, and then we have something that has this kind of quality, and then its complement is going to be everything that is not that quality. So let's say, for example, suppose our sample space is the colors of paint at the paint store. The complement of red would be all the colors of paint that are not red. So our sample space here is all the colors of paint. All right? And we have the red paint, and then we'll have what we would call not red. So not red could be green, it could be black, it could be white, it could be brown. What it is not, it's not red. Okay? So what we get is that if we think about our sets and we think about our sample space, the entire sample space, okay, is A, and we're going to utilize this thing, it's A unioned with its complement. So that's everything. Everything is in there because either you are A, in this case, red, or you're not red. And what this union sign means, it means we're going to put them all together. Okay? This is the entire sample space. Now, let's take a different example and see how changing our sample space actually changes what's in the complement. So suppose that our sample is now a can of red paint and a can of green paint. Then the complement of the red paint is just the green paint. So now what we're looking at is we've got red paint, and what not red is it's specifically green. So this kind of shows up a lot in things like, either you like Pepsi or you don't like Pepsi, or you are in a statistics class or you're not in a statistics class. These are called binary decisions or binary choices. And so they're binary because you either have one or you have the other. In our first example here with the paint store, we actually have a lot of different choices. Okay? But in the case of our second one, we're going to have one or the other. We're either going to get red or we're going to have green. Now, how does this relate to probability? And so it's kind of simple, and it relates to this idea that A union A complement, right, is everything. So if I take the probability of A and I add it to the probability of A complement, okay, what we want to think about here is when we think about probability, right, we're always taking it out of a total. So the number of elements in A we'll call that X. All right? And then we have our sample size is going to be N. That's how many total that we have in the sample space. Sample size is N. Okay? So the number of elements in a complement is going to equal N minus X. Okay, so it's going to be everything else. So when we add things together, how we look at probability from a definition standpoint, the probability of A, okay, is going to equal X over N, and the probability of A complement is going to equal N minus X over N. So when we add them together, right, these two, probability of A plus the probability of A complement, is going to equal X over N plus N minus X over N. And these are just fractions, and they've got the same denominator. So because we have the common denominator, we're just going to add the tops. So N minus X plus N over N is going to equal just N minus X plus X, plus X over N is just going to end up equaling N over N and equals 1. And that makes sense from the perspective that if I take everything in the set right? And I divide it by the total number of everything in the set, that's going to equal 1. All right, so that's kind of that idea. If we add up a value and its complement, it's going to end up equaling 1. If you add up everything in what we call a distribution, then it's going to end up equaling 1. So that's going to allow us to find the complement. So the probability of the complement, a complement, is going to equal 1 minus the probability of A. So basically, you're going to subtract, this is 100%, and it is going to subtract the parts of the whole that you don't want. So let's take a look at an example. So we'll suppose that we have 25 students in the class. "18 of the students passed the last midterm. What is the probability that a student did not pass the midterm?" All right, a couple things. Now I'm going to think about this. I'm going to think to myself, okay, I'm dealing with probability here because that's what I'm looking for. Probability that a student did not pass the midterm. Oh, and this did not. That's also really important. Okay? That's going to kind of shape my thinking. That actually is going to kind of cue me in that I might be looking for a complement. I might not, but I might. So let's say, for example, now I'm like, okay, well, I know something about probability. I find the probability by taking the desired results divided by the total number of results. And I know something about the complement. I know that the probability of, in this case, did not pass is going to equal 1 minus the probability that somebody did pass. And why that's handy is because I only know that 18 of the students passed. I know this value, but I don't know the other. Okay? So what that means is that I'm going to get, well, the probability that somebody did not pass is going to equal 1 minus 18 over 25, which is 7 over 25, which equals 0.28. Let's just confirm this with our calculator. 7 out of 25, 0.28. There we go. Now, it kind of makes sense too. If 18 passed, 7 will not pass. So another way to think about this is just we're looking for all the things that are not having the quality of what we said we had. Okay? So a couple things that we want to get here about complements. One, we want to think about our sample space. We have the idea of this is the thing that I know something about, and then I have everything else. Okay? It's, say, for example, in this case, not red and red. Then what I'm going to do is I'm going to utilize the fact that when I add together a probability of something and the probability of its complement, that it adds up to everything. It adds up to 1. So 1 minus the probability of that event will give me the complement. Okay? And this one here, this is like your big equation for understanding complements and probabilities. So what do? I'll find the probability of A, and then I subtract it from 1, and that ends up giving me the probability of the complement. And that completes this lesson.